I built a comfy UI clone. I'm going to show you how to do the same. I needed this because I'm vibe coding a video game and I wanted a way to create characters and animate those characters in a consistent way. AI image models are great, but they can't quite do this on their own today. Enter tldraw. Using tldraw and the workflow starter kit they provide, I was able to create a canvas that I can use to create animation pipelines and reuse them across my different characters. And because tldraw has an amazing drawing canvas, I'm able to draw and sketch directly on the canvas and then include those in the pipelines as well. In this video, I'm going to start by doing a demo of the final product. Then I will show you how to get started with tldraw and customizing the workflow starter kit. And by the end of the video, you will be able to create something similar.
Here is the final output. It is a GIF of a character walking with a transparent background, so it can be inserted into the game. The way this is created is with a pipeline of multiple steps. Let me walk you through a simple version, and then we'll walk through the full pipeline. So the basics of the workflow is generating a image from a prompt and then removing the background. Here we can edit the prompt. This one is just for creating a bow item, and then we can remove the background. So when we click play, the pipeline will start running, and in a minute here, we'll have a new item. So there it goes, and then we'll remove the background from it. And now that is done. So that is a very simple workflow. We can now elevate it by adding in drawing on the canvas. So these are two separate images that I've placed inside of this capture area. And the capture node allows capturing whatever is drawn in here. So if I wanted to mark this up, I could recapture this. And now there is a new reference image that is going to be inserted into the generate. So we can combine prompts, we can provide images, and we can provide reference images. Those are the raw ingredients of the pipeline. Now I'm going to walk you through the entire thing. To run a pipeline using the tldraw workflow starter kit, you just hit the play button, and this will run through each of these steps in turn. Walking you through step by step, what we have here is the baseline image that I am providing. And then we use a pass-through node to insert that into multiple spots in the workflow. Next, we have multiple capture nodes. These are all capturing the different postures that I've drawn over here on the left side. This is highly customizable. If I wanted to remove this head altogether, I could click recapture, and now that head has been moved. Next, we have a couple different prompts. These prompt nodes are just used to provide instructions on the specific step in the animation that we're working on. We then generate the image. This displays the output of the image. We've removed the background of the image using a Cloudflare API. And then finally, we combine it all into this GIF. And just like that, we can run the pipeline and create the new animation. And if we want to trade this character for any other character, all we have to do is delete this line, bring this character up, pull this up here, and click play again. And now it'll be working with this character. Now that pipeline just finished running, and we have this running animation for a completely different character in a very consistent way to the night animation that we created previously. Now let me show you how to build something similar yourself. Currently, tldraw publishes 4 starter kits. They're each great in their own unique way. And for this one, we use the workflow starter kit. You can get that at tldraw.dev/starterkit/workflows. And there is a handy little trial here right in the UI. You can see there are a couple different math nodes. You can set a value with a slider. You can add values together, click play to run that. The starter kit provides you all of that functionality right out of the gate. To get started, all you have to do is npm create tldraw latest and then select the workflow template. The starter kit also provides a handy conceptual guide on how the workflows work. The big things you need to know are a node shape, the ports and connections. The node shapes are essentially the individual nodes in the workflow that you are creating. These are highly customizable. Ports are how you connect different shapes together. You can have as many input ports or output ports as you want. It's really shape specific. And then the connection between the two, and that's how you map the logic of what is connected to what. The starter kit has some built-in logic for executing these workflows. For my use case, I was able to just use the out-of-the-box execution flow, but you can customize that yourself as well. With that high-level overview done, let's jump into some code. What I have pulled up here is NodeShapeUtil.tsx. This is the primary custom shape that ships with the workflow starter kit. All of the nodes on the canvas extend this class. This is the base class that encapsulates all of their display logic. So you'll see here that NodeShapeUtil extends ShapeUtil. ShapeUtil is how you Extending this is how you create custom shapes in tldraw in general. And this class really provides all of the information for how the shape should display on the canvas and provides plenty of options like, can you resize it? Can you edit it? How do you show the boundary of the shape? What is the geometry of it, etc. If you continue to scroll down, we'll see here in the node shape itself, this is the UI for displaying the shape. So we get the node's output, we check if we are executing or not, and then we can define how the shape looks itself. You can see here that I've actually commented out some test logic here. I just wanted to hide some of that UI to make it a little bit simpler. But if we customize anything here, it will be reflected across all of our shapes. Now let's dive a layer deeper into the custom nodes themselves. We'll start with the image generation node. I'll talk through a couple different examples. Here we can see that the image generation nodes extends a shared class for node definition. We add in some metadata like the heading and the icon for how it will be displayed in the workflow sidebar. If we change generate to include test here, we'll see that the header in the node itself has been updated. Continuing on, there are a bunch of helper functions like setting defaults, defining how to get the ports, and then the rubber really meets the road in the execute function. The way the workflow starter kit works is there is logic that collects the workflow and then iterates over each of the nodes, calling the execute function on them. This particular function, we want to get out the prompt input and then collect any number of reference images that are included via the ports. We update the shape to say that it is currently being run. And then we make a call to our backend API that uses the prompt and those reference images to generate the new image. This uses Vercel's AI SDK under the hood, calling the Google Gemini image model. After that, we get the image URL back and we store that data in the node so that way other nodes can build on top of it. The execute function is really the most important part of the workflow builder and is very customizable. Here in the image generator node component is how we define the UI for the node. We can also use the tldraw editor as needed. I have some logic in here for adding additional references or removing them. That is adding or removing ports to the card itself. And then we have some basic display information, essentially adding in the prompt port, any number of additional ports, and then displaying some buttons for either adding references or removing them. The background removal and GIF generation nodes follow a very similar logic. We essentially have an execute function that is collecting information, sending it to the backend, and then displaying that output in some way. Most of it is just getting the image back and then displaying it in the node here, along with some additional buttons for controlling the GIF. The next node that I want to talk about is the prompt node. Now, on the surface, it looks very simple. We're just capturing some text and then passing it on to a generate node, but it is a little bit trickier than that. In tldraw, there is a recommended way to manage state in the canvas itself. And if you try to naively add an input field onto a node, you might run into some render issues or the state won't update properly. So there are guides on how to manage this. I'll link this in the video below. You have an external UI context for controlling state from outside of the canvas into the canvas, or you can use these toast and dialogues. So what we've done here with the edit prompt is you click this button, it opens a dialog that's actually outside of the canvas. You can edit the text here, click save, and it'll update on the canvas. And I want to talk through just a couple elements that go into that. For the prompts dialog component, I've opted to use external UI using context. Let me walk you through what that looks like in the code. Here in the prompt node, I am using the context here, and I've pulled in a function for opening the prompt editor that accepts the editor, the shape, and the given node. Here in the context, we essentially establish that functionality, the logic for opening the prompt editor, for closing the prompt editor, and this controls the logic for actually updating the node itself as well then in this handle save function. So essentially we pass in the editor to this external UI. It's able to then update the node with any text that is submitted by the user. And then I just wrap the entire tldraw app with this prompt editor provider. And now I can use this prompt dialog anywhere in the application. I want to call out here that editing state especially using something like a dialogue, does have some recommended best practices for tldraw, and there are some documentation here on how to do that. There are a number of ways you can opt for what makes the most sense to you or what fits best into the flow of your app. The last node I want to walk through is the capture node. This is a special node that allows us to capture a specific area on the canvas and translate it into an image that can then be passed along in the workflow. Here we have the capture node, and the way this works is we can select a unique region on the canvas to capture. When we click recapture, it'll update with any shapes that are in that area, and then we can use it as an image. For example, if I draw a circle here and then click recapture, this is now a circle. I'm going to click run on this, and I'll wait a sec to show you the image out the other side. All right, we can see the make this cooler prompt. It now just created a kind of galaxy orb. If we want to draw more onto this, make it a stick figure, we can, and then we'll click run. We'll click recapture and then we'll click run. I forgot to do that. And now we can see this crazy galaxy stick figure. One nice thing though is we can resize this, and we can also use just the built-in shapes from tldraw. Let's say we wanted to make a house figure here. We can add that, hit recapture, and now run it again. There we go. That's pretty neat. So that's one of the beauties I think of tldraw, is you can build this really complex workflow pipeline on the canvas, but you also have these great drawing features available as well, and integrating them too unlocks a lot of really neat capabilities. Let's jump into the code for the capture shape. There are two pieces to this. One, we have to have the node for actually capturing and providing that image, but we also have a custom shape that is referenced by the capture node. Here in the capture node, we have a function for handling capture. And really the magic here is in calculating the shape boundary, the region boundaries for the given shape. We can identify all of the shapes within that area then, and we can create the image using the editor.toImage function. So essentially the three steps are there. We identify the shape that is our capture region. We then collect all of the other shapes that are in that box, and then we can use the built-in editor functionality to convert that to a PNG. That's actually what's saved here, is just a PNG, and then it gets passed along directly into the generate node. That means we also need to create a custom shape for capturing that region. And you'll see here in my capture region shape util, I have the logic defined for that. We extend the base box shape util. That's just a handy little starter class, essentially. We define some basic information. We do allow this shape to be resized, unlike the NodeShapeUtil that we walked through earlier. We define the rest of the required functions here. We provide some resize logic as well. That's our crash course in the tldraw workflow starter kit. We learned how to create custom shapes, how to customize nodes on the canvas, how the control flow works in the pipeline, and more.
Thank you so much for watching. If you want to see more content like this, please like, comment, and subscribe. I cannot wait to see what you build with the starter kit. You can check out the SDK at tldraw.dev.